Good Monday morning. Today we're going to code a neural network from scratch in JavaScript. No libraries, no assumptions about knowing math because I don't know any math. I don't know statistics. I don't know AI. I only have a very vague idea about what a neural network is from some YouTube videos I watched. I have been procrastinating on learning machine learning for so long. Let's just do it. I am MPJ, and you are watching Fun Function.
That's your computer, your friend. It is your friend.
Today's show is sponsored by Pusher. Pusher makes it easy to add real-time communication and collaboration features to your app. Chat, PubSub, Mobile Push, and Feeds. Check them out at pusher.funfunfunction.com. That link is also in the episode description. Sweden is very warm, so my energy levels might be steadily dropping until I die in this episode. Alright, so last week I watched a video by Daniel Shiffman on the basics of implementing a neural network. I like Shiffman. I wanted to get started with machine learning, and I just figured that, hey, neural networks, that sounds cool, let's start with that. I streamed it on Twitch. I sometimes stream on Twitch, so if you don't follow me on Twitch, you should at twitch.tv/funfunfunction. Twitch is still a little bit of a hobby, but I really like doing it. It was a great deal of fun. Didn't turn out too well though, as in terms of results. I didn't really complete the neural network, but I've been fiddling around with it a little bit more, and I think I have something to show you from what I've learned. So in this machine learning series, I'm going to try to piggyback a lot on the fact that I don't know anything. I don't know much Python. I don't know much about math. I don't know much about statistics. I don't know a lot about probability. I don't know a lot about machine learning and AI. So I'm going to be utilizing that beginner's mindset and try to use the space from where just when I learn something, I'm going to try to still remember what it was like before I learned it, and I'm going to use that to make these videos for you. So I'm kind of making these videos for myself, but like 2 days ago. Hopefully that will turn out into interesting content, or it might just be very messy. This is a new and experimental way of doing videos for me, so we'll leave your comments down below after you've watched it, what you thought about it, and how I can make it better, or if I should just throw it away. Anyway, let's get going. Have a look at this. I'm using Observable notebooks because they are amazing. Not getting sponsored or anything, they're just these really handy interactive notebooks. It's kind of like JS Fiddle, but you can actually store data, and oh, they're so good. I won't go into a high-level explanation of what a neural network is, honestly, because there's already pretty much the perfect video on that exists already by 3 Blue 1 Brown. But what is a neural network? I've linked it here. Just look at that first before viewing this video if you're unsure what a neural network is. It's going to give you a good sort of high-level overview of what it is. It also goes into a couple of mathy details that they're going to be scary, but don't worry about it. We're not going to go into that. Just try to, like, oh, there's math. So our goal is to make like an ultra simple neural network. It's like the silliest little neural network. Like it's not even a network. It's just one brain cell, one neuron, perceptron, whatever like words they use. We're not going to use those words. We're going to try to focus here on getting the principle right. So I'm not going to spend a lot of time in words. I'm not going to spend a lot of time in the brain analogies, wooden axons and neuron, like blah. That's not really important. I don't mean to shit on all the interesting research that has been done on that, but I find that getting confused and into the math and the brain science of things is kind of distracting. Has been distracting for me when learning these things. I just want to get to the essence of it and understand how it solves problems. After that, well, then we can go dive into the interesting aspects of what lies beyond and how it connects into everything. But for now, we're interested in looking at what a neural network is and how it works. So we're going to build a little silly neural network, and the purpose of this little silly neural network is to classify on what side of a coordinate system that a point is. So you just imagine a coordinate system, and this like line between it, and then there's a bunch of points. And then the neural network, we will teach the neural network to figure out if a point is on this side of the coordinate system, or on the line going through the coordinate system, or on this side. It's not a very smart AI that we're building, but you know, baby steps. Building Skynet is it's a later part in this series. Okay, let's begin we're gonna generate a bunch of random points, you know, like points with x, y coordinates in a coordinate system. In machine learning, there's a lot of coordinate systems. That's a little bit of math and it's a little bit of geometry there, which might give you flashbacks from high school or whatever, but like, try to breathe. The first thing that we're going to do is to pull in Ramda. Require Ramda. This is one of the nice things about Observable, is that you can just pull in NPM modules. It's really nice. So let's create some random points. Random points. I'm going to use the rrange function. And the rrange function gives us like numbers from 0 to 5. Z, like it just gives us, you know, the numbers 1, 2, 3. I'm really not interested in the actual numbers here. I just want an array that is 100 long, so that I can do map on it, and then I don't really care what is in the array. I just want to you know, do assign a random number there, and This was like during the stream, one of the stream viewers actually wrote this function for me, which was nice and interactive. There's great. And we want the numbers to range from -1 to 1. So you see here that we get, like, you see, like, it ranges from -1 to 1. It just right. This is a bunch of random numbers. By the way, you might take offense to this syntax here. This is observable, an observable thing. This is not strictly a global variable, like plain JavaScript would interpret it. This is actually creating an observable. So if I do like random, I can do random points dot length here. Random points there. So whenever I change this range here, you want to watch this number here, I change this to 200, that will automatically update. So that this is how, this is a basic atom or thing in Observable and how you declare them. So it at first it seems like a disgusting syntax, but it's actually really really nice to deal with. Anyway, this is not actually points yet. It's as you see, it's just numbers, but a point is an x coordinate and a y coordinate. So that is what we want. We want an x and y coordinate. So we're gonna write an x and we're gonna write a y. I am trying to be really, really happy even though it is so warm. Cool, we now have some x and y coordinates, that's nice. All right, I want to make this as visual and interactive as possible so that you don't need to like execute a lot of code in your head and keep abstractions in your head. So in the series, we're going to try to, as much as possible, constantly visualize what the hell is going on. So I'm going to draw the coordinate system, and we're going to draw it with SVG. What, MPJ? Bear with me, it's going to be cool. Okay, it drew something, but it draws everything in the top left corner. And that is because, you know, the random points that I just keep it with between -1 and 1. And I don't know why I did that. That was just dumb. Let's not do that. Instead, I want to keep them between like how big the coordinate system is. So I'm going to like make these variables. So I'm going to call this x max, and I'm going to call this y max, and we're going to create them y max 400, and I'm going to also do x max 400. 400. By the way, when after I finish this episode, I'm going to put this notebook public, so you can find it in the episode description. It's not gonna have this URL; it's gonna have another URL in the after it's published. But you're gonna be able to find it, and you can play around with it yourself while you're doing this, or you can just create it from scratch and follow along. Anyway, let's see. X max here, and the random points has to be generated from this. So x is going to be 0 to x max, and it's going to be 0 to y max. There. And then it didn't work at all. Not whatsoever. Shit. Let's have a look at these. What it look like? These actually look fine. Can I inspect an SVG? The SVG, what is it? It only draws one circle, and then there's circle inside the circle, and then a circle inside the circle. What? Inception! I didn't want Inception. Oh, it's because I'm not closing the tag. There we go. Ha ha ha! Okay, radius 5 is too big. Radius 3 seems more sane. This shows you a lot of the power with Observable. Let me just, when I regenerate points here, you see that it's updating. Everything is observing and reactive and nice. Super cool. I love Observable. Remember that I said that we wanted to start classifying what side of the coordinate system the circles are. Or not the circles, the points that we are drawing circles for. We have the data, and then we have the visualization of the data. Anyway, I'm gonna draw a line. Ah, come on. No. Oh, there as well. Yes. Okay, let's draw it. I want it to be purple. So we're going to call this team team 1, and we're going to call this team -1. So 1 minus 1. And I'm going to write a little function that we call team. And it's going to be take a point. And if the point x is above point y, it's going to be team 1. Otherwise, it's going to be team -1. And then I'm actually going to use this function here to give it a different color so that we make sure that our function is correct. All right, so it turns out that this team is team -1 and this is team 1. Now, the tricky thing with teaching machine learning is that the examples that you need to use in order to understand what the hell is happening are so simple that you might as well have used code, and that is definitely the case in this case. So if we look at this, we have already solved the problem here by using this little team function. This team function takes a point and then it actually correctly classifies a point. So in this problem, this is a very, very, very simple problem to solve. Because it has only two inputs. It has an x and a y coordinate. That's all that determines how where in what team a point ends up in. And the logic is also very simple. It's just if X is bigger than Y, then it ends up in one team or another. And in real life, we have much more complicated classification problems. For instance, let's say that you have a bunch of data on house prices. House prices is a classical problem for this. So every row might be like a sale of a house. So instead of these things, these random points, X and Y coordinates, it might be just houses in a long list. And each table row of these houses, they have like a square, like how big the apartment is. It might have square meters or square feet or whatever you use in alien land. It might have where it is located, what area it is located. It might have like the year that the building was built, the number of rooms, and it might have like 20 of these. Might have, in more complicated problems, there might be hundreds of these things. In this problem that we're looking at here, it's the X and Y, the coordinates, but in another problem, it might be aspects of a house that affects the price, such as size and location. And in another problem, it might be flowers, it might be petals and petal size. Like when classifying images of animals, it might be how pointy ears they have, like if they have whiskers. And what we want to do is that we want to take all of these inputs or traits or whatever we want to call them, and we want to garble them together somehow with some logic. And not really like if we did it with programming, we would use logic. We use a lot of if statements and perhaps if the house price is this and like if it's the location is this, then this might affect and like. But it works in this simple case, but in the house pricing case, it's gonna be extremely complicated, and it's just code is not very suitable. If we created a housing price predictor, we would take all these housing prices and garble them together and somehow produce an output price based on all their inputs. So with the housing prices, we wouldn't be able to visualize this with a 2D coordinate system because there would be way more dimensions to the problem than there are coordinates in real life. Like it would be not 3-dimensional, it would be like 13 dimensions, and humans can't visualize that. That is when machine learning becomes very abstract and very useful. But that's not what we're gonna do today. The reason that I explained that is to give you an idea of why we use machine learning and you have to use your imagination a little bit to understand the why of this, because. But in this case, where our problem is very pedagogically simple and it's just these 2 points. Let's create an AI. We're gonna create a function called guess that does exactly the same thing as team, but instead of using logic to determine where a point is, instead of using math, it's going to use machine learning. So let's just start. Just bear with me here. Yes. It's a function, guess is a function that takes weights and it takes inputs. And inputs is like, that's a general term for things. I'm just gonna call it point, because a point is our inputs in this case. Remember that the inputs in this case is just 2 points on a coordinate system, an X and Y. But in a neural net, it might be like housing prices or like cat's ears or whiskers. It might be like a list of things, and that's called the inputs. But in this case, the point is fine. Otherwise, we might get confused if we try to think too much about the abstraction. Yeah, let's just so let's start there. We are going to need some weights because otherwise we will get confused. What are the weights? The weights are kind of the brain state of our AI. the weights is what we're going to be multiplying everything with. And the weights, they're gonna start out random. The AI is gonna just have some weights. And then it's going to, we're going to train the AI. We're going to have the AI guess, based on its random weights, what a given coordinate is, what team a given coordinate is. And it's gonna guess wrong, because the weights are random. It's gonna just multiply weights, and it's gonna be off. But we are then going to give it the correct position, because we know that position. In this case, we have a function that gives us the correct answer, the team. But in real life, we would have like the actual sale prices for houses that we could give it. And when we give it that, it can see, how wrong was I? Okay, I was this wrong. Then I adjust my weight a little bit towards that wrongness. If that's the gist of it, don't worry if you're confused. That is normal. This is not intuitive in any way, but let's just bear with me. I'm just trying to give you a sense of where we're going before I start coding. So just try to follow along. Random weights. Oh, yes. Okay, we have some random weights. It's an X and it's a Y. Okay, this is the weights. This is the initial state of our little AI. This is how its brain looks like inside. It's pretty nonsensical, and it will continue to be nonsensical, but it's even more nonsensical now because it's just two random numbers. So if weights is the brain of our AI, then guess is the skull that we're going to put that brain in, and that is why it takes weights as an argument. So how does guess use the weights to think? I'm going to show you that, but first I'm going to switch shirt and probably switch lighting and hairdo and maybe complexion as well, because I'm going out and meeting some friends. I'm continuing this later. 1, 2. Hello, I'm MPJ from the not too distant future. I'm indicating this by this hat. I'm sitting around editing this video, and I realize it's very long, so I've split it into multiple parts. So cliffhanger, please remember that this episode was kindly sponsored by Pusher. So please check them out at pusher.funforfunction.com. You can subscribe here so that you don't miss the next episode on Monday. Or if you are watching this from the future, then you can watch the next episode right here. And otherwise, this is going to be just a recommended video, I think.